Welcome everyone. I'm Luke from Giving What We Can. The organisations and panellists here today are all organised a common desire to use evidence and reason to figure out how to best contribute to helping others and take action on that basis. Today we're looking at the topic of climate change and how we can use our resources to do the most good there and how big the problem is compared to other problems as well. It's my privilege to introduce our panellists today. First off, we have John Halstead from Forethought Foundation, who's focused on climate change. Prior to that, he was head of applied research at Founders Pledge, a philanthropic advisory service to tech entrepreneurs, and a research fellow at the Global Priorities Project. He has a DPhil in political philosophy from Oxford and has published on a range of topics, including philosophy, economics, and climate change. John, welcome.
Thanks. Yeah, happy to be here. So I'm John Halstead. I'm a researcher at Forethought Foundation, which is a research institute based in Oxford that works on long-termism and issues surrounding that. And my presentation today is about how we should prioritize climate change from a long-termist point of view. This is the summary of my talk. I'm going to start by defining what long-termism is, and I'm then going to discuss a view which I think maybe overstates the risk of climate change, and I'll then move on to the main focus of my talk, which is a discussion of a climate scenario that is potentially quite worrying from a long-termist point of view, and that may affect how it's prioritized within effective altruism. So first, what is long-termism? Well, roughly and briefly, it's the view that what matters most about our actions is their impact over the long-term future. And when we say long-term future, there we mean no limits really, so thousands or millions of years. And why might one think that long-termism is plausible? I think the answer in brief is that because so much of our potential is in the future. Homo sapiens have been around for about 200,000 years, and even if we just stay on this planet, so we don't go to other galaxies or stars, the Earth is going to become uninhabitable in about 500 million years. So we've only really realized a fraction of our potential as a species. What that means is that kind of whatever you think is morally valuable, whatever you care about, or like whether it's just welfare or utility or friendship or beauty or justice, there's much more to come in the long-term future. So protecting the long term and ensuring that it goes well is really important. That's what long-termism is. What's near-termism? Well, that's the view that what matters most about our actions is their impact over the near term. So that's usually a time frame of less than 100 years. And near-termist people typically will focus on things like poverty or farm animal welfare or suffering. And I think ideally we'd find causes where there's kind of like a concordance across moral views on things that are important. So are there near-termist reasons to care about climate change? And I think there are. Like, I do think it's true that most of the costs of climate change are going to arrive at the end of the century or beyond. But the burning of fossil fuels releases lots of air pollution, and that kills millions of people. It's one of the biggest public health problems. And I think for that reason, we have ample motivation, ample reason to make strong reductions to fossil fuel emissions. So happily, there are also near-termist reasons to care about climate change. What's the long-termist case for focusing on climate change? I think it at least seems so far that the case for focusing on climate change hasn't really been obvious. But before we get into that, it's useful to consider a key definition, how I'm going to be understanding what a catastrophe is in this talk. And I'm defining it in this very specific and extreme way, which is an event that threatens the long-term flourishing of humanity. So that could be human extinction, when absolutely everyone gets killed, or it could be permanent societal collapse. So, there's like a huge economic collapse, perhaps due to a war or something like that, and humanity just never recovers. So that's what I'll be understanding by catastrophe. And I think so far, climate change within EA has been prioritized below other risks like biosecurity and artificial intelligence. And And that is because climate change is generally seen as having lower risks of catastrophe than these other risks. Climate change is also prioritized below meta things like global priorities research and other things like institutional decision making. A common reason given is that it's less neglected, which I don't really buy that argument, but that's I'm maybe outside the EA mainstream on that one. But certainly the long-termist argument for focusing on climate change hasn't been that strong so far, or hasn't been that obvious so far. One view in certain circles amongst certain journalists and activists and scientists is that catastrophe waits at 5 degrees. So we've had around 1 degree of warming so far since the Industrial Revolution. And on business as usual, which is shown by this red line on the chart, we're headed to about 5 degrees by the end of the century. And some people think that that would be catastrophic in the sense that I've defined here. I'm not going to discuss this view in much depth for time reasons, but I will say that I don't really see the mechanism by which that could be true. So if you just consider one potential impact that some people talk about, which is impact on the food supply, this is the IPCC's view of the impact of local mean warming in different regions and on the major food crops with adaptation up to 5 degrees. You can see that really the effect on food yields is just not really big enough to threaten the global food supply. And you have to bear in mind that these effects will take place over decades, and there'll be other countervailing forces that will probably improve food supply and productivity. So for example, since 1960, food yields for most of the major food crops have increased by about 200%. So the effects with food just don't seem big enough, and I think that's true for other potential mechanisms as well, but I'm not going to go into that. Maybe we can talk about that in the Q&A. One thing I think it is more concerning from a long-termist point of view is this boom and bust scenario, which Will MacAskill has raised to me, so he gets the credit for this idea. And the scenario is as follows. First, there's very high emissions. Secondly, as a result of that, we get high warming. And then step 3, there's a collapse caused by some other process like a war or use of nuclear weapons or the escape of an engineered pathogen, something like that. And then step 4 is this terrible future in which we're stuck in an inhospitable greenhouse world for tens of thousands of years. And I'll now discuss how that might go. So step 1 is very high emissions. And what reason do we think that emissions would be really high, maybe higher than a lot of policy people or the scientific community thinks? Well, one argument is just progress so far is not very good. This chart shows low carbon energy as a fraction of total energy consumption. And what you can see is that the share is just not really increasing very much despite all this attention to climate change over the last few decades. And what we've seen instead is just this exponential increase, literally exponential increase in fossil fuel burning. And the problem we face is that we need to reduce fossil fuel emissions substantially while also meeting the energy needs of growing economies, especially outside the West. So our decarbonisation challenge plausibly looks a bit like this. We've got this doubling of, what this shows is a doubling of energy demand by the end of the century, and then us having to make this massive course correction, completely dismantling all of the infrastructure for modern industrial society and replacing it with low carbon infrastructure over the course of a few decades is a big ask. Just some key stylized facts are that there's, according to the UN, there's going to be 2 to 5 billion more people by the end of the century. According to expert surveys, incomes are going to be 2 to 20 times higher. So a doubling definitely seems on the cards of energy demand, and you could imagine the case for a quadrupling or a quintupling or something like that, in which case this graph would look even more extreme. Energy demand growth so far has just been fossil fuel growth for the most part. And then, as I said before, like an exponential fits the trend in emissions so far quite well. And if this continues, then we'll just burn through all the fossil fuels by 2180, which amounts to putting about 12 trillion tons of carbon into the atmosphere, which is a lot. So that takes us to step 2, which is following high emissions, we end up with very high warming. So the highest emission scenario considered by the IPCC, we burn about 5 trillion tons of carbon, which leaves us most likely with something like 10 degrees of warming. But there's the numbers below the below the 10 in the little boxes shows the 95% confidence interval. So there's a 95% range from 6 to 16 degrees in that case. The heat map on the right shows the effect of 12 degrees of warming on heat stress across the world. So anything above 35 is basically considered a lethal level of heat stress. This is the white and sort of purplish areas of the graph. And you can see that in this 12-degree world, these lethal levels of heat stress are enveloping most of the most populated parts of the world. So we're looking at much of Latin America, much of Africa, India, the Persian Gulf, Australia, and the US. So at 12 degrees of warming, you are getting this very, very different world that seems much less habitable across the tropics. But things could be much worse than this, really. As I said, I don't think we can rule out this negligible possibility that we'll burn through all the fossil fuel resources just on the basis of how things have been going. And that means we put 12 trillion tons of carbon into the atmosphere. And then warming could be really, really high. We could get past 20 degrees, so maybe some chance we could get past 30 degrees. And that would certainly make the world very unpleasant for even at higher latitudes. The heat stress would become very unpleasant, and it would pose challenges to agriculture, outdoor agriculture, because the thermal tolerance of plants would be past. In the oceans, I think it would be a major threat to marine life to have such rapid warming and ocean acidification at the same time. It would probably pose the risk of a mass extinction in the oceans. So it would be this very, very big deal. I mean, another reason we might worry about this very extreme scenario is that there's lots of unknowns in the climate system. So you can see this chart on the right shows the path of CO2 concentrations in the atmosphere since the Cambrian explosion, more or less, over the last 400, 500 billion years. It fluctuates a lot naturally due to volcanoes and other things. But what we're doing is kind of unprecedented on geological times in terms of the amount that we could eventually emit and the speed at which we're doing it. So the 12 trillion ton scenario is shown by the black line on the right hand side of the chart, and that takes us to about 5,000 parts per million, which is plausibly higher than concentrations have been for about 500 million years. So we don't really know what would happen if concentrations passed that level. We don't really know what would happen if concentrations passed 2,000 parts per million, because that hasn't happened for at least tens of millions of years. And most of the climate models we have break if you emit this, if you try and run these simulations, because the effect is so big. So there might be some nasty surprises around the corner if we actually continue with this unique planetary experiment that we're carrying out at the moment. As just one example, there's a paper by Schneider et al. From 2 years ago, which shows the clouds burning off if we go past 1,300 parts per million, which would cause 8 degrees of warming over the course of days, or potentially months, or years, depending on which assumptions you plug into the model. But certainly there's this decidedly non-linear feedback that kicks in once warming gets that high. Like that's controversial, but there's definitely reason to think there might be something unpleasant around the corner. But one thought is, hang on, when we adapt, even in this scenario in which we go past 10 degrees of warming, it does seem like there's lots of scope for adaptation and lots of scope for response. The main reason for this is that high emissions are for the most part driven by high economic growth. So on the high emissions scenario considered by the IPCC, that's driven by an increase in per capita income of more than 1,000% by the end of the century. So in that world, we're a lot richer. The technology is kind of unimaginably improved and different compared to what it is today, just as the technology today is unimaginably improved compared to what it was in 1900. So that means we can adapt. Maybe we could create these, it just seems feasible that we could create these like vast air-conditioned environments. We could have indoor hydroponics, which we already have today. That's how people grow food in Antarctica, for example, like scientists and researchers. We'd have new technologies like nuclear fusion, things like that. Maybe advanced renewables or advanced nuclear fission, advanced storage technologies. And we'd also be so rich that it wouldn't be that much of a hit to the bank balance to start to suck CO2 out of the atmosphere, which basically means we could just kind of change course as we got richer. The problem comes because there might be collapse for other reasons, and that's step 3. So it might be that we emit a lot of CO2 and we start to face all these costs. That might be because just coordination is much harder than we think, or it's broken down because there's a sustained Cold War or something like that. But society might collapse for other reasons, perhaps due to an engineered bioweapon or to a nuclear war or some other thing that we don't understand yet. And perhaps that kills 99% of the world population. So that kind of takes away our ability to adapt and our ability to respond. The problem then is that CO2-induced warming lasts for ages. It lasts for tens of thousands of years. It takes a really long time for natural geological processes to remove CO2 from the atmosphere. So the chart on the right shows the climate response to a given amount of emissions on a simple model. So this is just like, we emit loads of CO2 over the space of 100 years. And then we reach the peak kind of within either immediately after stopping emitting or within like 500 years. And then unfortunately, 70% of the peak warming remains at 10,000 years. So say we get to a peak of 8 degrees of warming, we still have 6 degrees of warming at 10,000 years. So, you know, if we went to 20 degrees, we'd still have 14, 15 degrees after 10,000 years. In this respect, climate change is kind of the ultimate long-term problem. When you drive your car or take a flight, there's a chance that you influence the temperature of the world for millennia, for good or ill. And in the case in which the temperatures are very high, that makes civilization recovery a lot harder. And it makes it a lot harder for a very long time. That's one reason we might care about climate change from a long-termist point of view. So in summary, I think this boom and bust scenario is probably like the main reason to be concerned about climate change, and it's one that hasn't really been discussed that much and will only really start talking about recently. It's still not really clear how climate compares to other causes given this new argument, but it's sort of worth considering. And it is a difference between climate change and other risks like nuclear war and biorisk. If there's a nuclear war and a nuclear winter, the ecosystem kind of bounces back really within the space of less than 10 years. And maybe similarly with a biocatastrophe that doesn't kill everyone, the environment is kind of back to normal, relatively sharpish. Whereas with climate change, we're sort of stuck in this potentially very unpleasant world for a really long time, which really limits our ability to respond. So when we're thinking about solutions, we might want to start focusing especially on solutions that are robust to breakdowns in cooperation that might cause very high emissions, and that might cause collapse. So if there is a Cold War or something like that, or some other breakdown in cooperation, we want a solution that's sort of robust to that. And I think one solution that's robust to that is energy innovation. Because if, say we make solar power really cheap and storage really, really cheap, that technology, that know-how is then kind of just there for the world, and it's not really reliant on cooperation. People just use it because it's better. Whereas if we're saying like we need a $100 per ton global carbon tax or something like that, then in the low cooperation world, or the world in which we're really poor because there's been a societal collapse, that doesn't really work very well. So yeah, I think it counts in favor of these more cooperation light solutions to climate change, like energy innovation. And that concludes my talk. Thanks very much.
Wow, thank you so much, John. That was really insightful and very helpful for me personally in understanding this from a long-termist perspective. Next, I would like to introduce Johannes Ackler. Johannes has dedicated much of his adult life to the topic of climate change, from a teenage environmental activist to a climate policy expert, advising major EU decision makers. Johannes is committed to solving the problem of global energy poverty while simultaneously reaching net zero emissions and protecting our planet. Prior to joining Founders Pledge, Johannes spent 5 years working in a think tank advising decision makers on climate policy and conducting academic research into the intersection between effective and feasible climate policies. Leading the climate research at Founders Pledge, his research has been featured in Vox. He's a regular speaker at effective altruism events, and he advises many organizations on their climate change philanthropy. It's my honor to introduce Johannes here today, and he's going to talk about charities and relating to climate change and the research process that Founders Pledge has done to get to that point. Johannes, welcome.
Yeah, thank you very much, Luke, and thanks, John, for the talk on the long-termist import. Can you see my screen now?
Yes, and just a reminder to people to submit questions using the Q&A function, and then we're going to have a Q&A at the end of this presentation for both of the presentations. Thank you very much. I'll leave you to it.
Yeah, thank you. So yeah, John has kind of talked about the long-termist import of climate change. What I'm going to talk about is like, given the importance of climate change, and if you want to do something about climate change, how can you actually have the biggest impact to reduce climate risk and damage from climate change? Yeah, but before I do that, just to quickly introduce also the team at Founders Pledge, because right now I'm presenting, but all of this, of course, is teamwork. So Anu Khan, Louisa Sandkühler, and Violet Buxton Walsh are also contributing to this work. So yeah, today I'm kind of talking, but this is obviously a team effort. And to kind of answer the question, what should we actually do to minimize climate risk directly in the beginning? Yeah, so the answer kind of is you want to support solutions that have leverage on global emissions, because this will minimize the likelihood and the badness of dangerous climate futures. And the rest of the talk is really kind of trying to explain what that means and what kind of the solutions, and especially what the charities are that you can support. But first, really, of course, to understand like what are the solutions, we need to understand the problem. And John talked about this a lot, of course, from one particular angle and with one particular perspective. So like a long-termist perspective, and kind of focused on one particular risky scenario. And what I'm going to do is kind of I'm going to get the space a little bit more general. So like John's example is kind of one of those things that I'm really worried about, and that's kind of part of the world, but I'm again trying to kind of give it into a bit of a broader kind of context. And yeah, kind of answering where's the climate risk at. And the first thing to note, and that's something that John has already stressed in his presentation, is that if we look at the different kind of futures that the IPCC distinguishes, there's huge variety in how much energy demand will grow. There's lots of different futures we could end up in, so-called, and the IPCC calls them shared socioeconomic pathways. So these are scenarios about the kind of worlds we're going to be in. And some of those energy demand is going to increase by 3 times or 5 times even compared to today. And of course, if energy demand increases so much, that possibly has a possibility of really high emission futures. And then the second key part about this is that in those worlds where emissions are high, so for example, what's called the pathway 5, fossil-driven growth, or also the pathway 3, regional competition. So those are the two with the highest average emissions. And in those worlds, also, these are worlds of low coordination and of low willingness to pay for climate. So we're kind of getting into the situation, the most risk in terms of the emissions is also kind of the world where we're kind of least able to address that, where our solutions that we usually would rely on, like global agreements, etc., are unlikely to work. So essentially, kind of generalizing, this is true in this one scenario that John talked about, but it's just generally true. The most risk kind of is in those futures, high growth, low coordination, low climate policy futures. And that's the same whether you think about this as a long-termist or as a short-termist. So kind of course, that's the risk where existential risk is probably the largest, or climate contributing to other existential risks as a risk factor. But also just if you care about the future, if you care about the short-term future, this is kind of where most of the damage, most of the climate damage is at. And of course, there's something else that's really crucial about climate change, which is that, I mean, and that's also something that John already alluded to, that worlds where there's more warming, like the climate damage is very nonlinear. So here, for example, these are different models. So on 6 degrees, this is something like much more than like twice as bad than 3 degrees. It's more like 4 times as bad than 3 degrees. And maybe something like 10 times as bad as 1.5 degrees, even though the difference is only a factor of 4. So climate damage is highly nonlinear. And so most of the damage is in those highs, most of the damage risk in those really high emission futures. So it's not about whether we miss the 1.5 degree target and get to 1.8 degree or something. It's more like, how do we avoid 6 degrees? And yeah, so there's much more damage and much more climate damage and higher warming scenarios. And if you kind of combine those two aspects, kind of, you kind of get to what I would call like the shit hits the fan principle, which is kind of to say, okay, if you want to look at like high impact interventions in climate, you want to focus on stuff that works when really you're having really really unfavorable conditions. So when you're having lots of energy demand growth, when you have low climate policy coordination, that's kind of the world that you want to have robust solutions towards. And yeah, so that's, I think that's also something that John already alluded to. What does it actually mean? It means that we need to have solutions for, or climate solutions for a world where energy demand is really high and coordination is really low, and energy innovation is obviously probably one of the primary strategies for that. And you can see this here again. So this is only a middle of the road scenario. So it's actually very close to what I showed before, SSP2, which is it's called middle of the road scenario. It's not an extreme scenario. So in an extreme scenario where we have really high growth, energy demand growth would be more something like going up much more steeply, quintupling, etc. So like in that world, climate change is really hard. If there are also some models that cannot produce climate stabilization in these scenarios because the socioeconomic conditions are just too hard to kind of reach climate stabilization. So that's kind of the challenge that we're facing. So it's a daunting challenge. How can we actually make a big difference, and how can we, especially as like philanthropists, people who can use money, how can we actually really make a big difference for such a daunting challenge? And I think the answer really clearly is we have to be really strategic and bold in the solutions that we're choosing. And yeah, so we kind of don't take a fatalistic attitude from that. So like the challenge is daunting, but we can absolutely have really large impact, just as in other causes. The very best solutions can have a really high impact, and that's also true for climate. But, and that's really one thing that's key about climate, because climate is such a, on the one hand, it's a really big challenge. On the other hand, it's also a challenge where there's lots of societal attention. The way to really get to high impact solutions is to kind of find things within climate that give you leverage towards the resources that you're spending to have much higher impact for your resources than you could otherwise expect. And that's what I'm going to talk about next. So one of those, and there's essentially like 3 of those impact multipliers that I'm going to talk about. The first one is audacious advocacy. So like if you're choosing charities, focus on charities that do advocacy, because this is the most plausible way to kind of get leverage on your emissions. So don't plant trees, but focus on charities that kind of do advocacy that leverages public resources. The second one is, what should this advocacy be about? It should be on areas that are neglected compared to their potential, of course, focusing on blind spots. And the third one is doing so in a coordinated way. And that's where I'm going to talk about the climate fund that we have at Founders Pledge and why we think that actually increases the impact you can have, at least, again, by another factor of 2 or so, at least. Yeah, so kind of going through this, A for audacious advocacy. And that's really where the good news kind of story starts, because the climate is obviously a really hard problem. But I think the thing that we've all realized over the last 2 or 3 years is that the climate conversation that we're having now, the climate conversations have really changed fundamentally. So the attention to climate has been rising, kind of, I think, hasn't never been on the same level, and it's really orders of magnitudes larger than it was just like 3 or 4 years ago. And you can also see this in the resources that societies deploy to kind of solve the problem. So just for example, if you kind of compare what Obama was passing in the green stimulus in the last Great Recession in 2009, was like something like 90 billion for clean energy. What Biden is proposing now as part of the infrastructure bill is more than 10 times higher. You have similar patterns across the world. And this really means that you have extreme leverage, or you can have extreme leverage if you're funding advocates that are using those resources and making sure those resources are spent in a better way, because by default, there's special interest politics, there are ideological forces at play. There's a focus on national emissions rather than global emissions. So by default, those resources will not be spent well, but you can obviously really strongly improve that. That's the idea behind audacious advocacy. And to just give one example of this, which I've showed before, but just to kind of explain the logic, is looking at 45Q, which is a tax credit for carbon capture. Carbon capture is one of those technologies where the IPCC and essentially every expert panel says, okay, we will very likely need this technology, and especially if we're in those high emission futures, but it hasn't really taken off until now. And so we're going to look at a campaign that the Clean Air Task Force kind of worked on and was probably responsible for, or at least partially responsible for making this policy happen. And this has now resulted in 45Q being the most important like incentive policy for this technology in the entire world. So it's kind of a really significant policy for a key technology. And if we're kind of looking at what could this do, even under extremely conservative assumptions about the impact of like the charity of the Clean Air Task Force, it looks really, really cost effective. So it could save something like, this policy could save something like 49 million tons per year by 2030. And even if you would say, okay, Clean Air Task Force has only moved this forward by 2 years, and there's only like a 5% chance or so that they were essential for this. So even under those really conservative assumptions, you're getting to something like 1.60 per ton of CO2. So, and if you think about how you can otherwise reduce CO2, for example, if you're trying to buy high quality offsets, you'll easily pay something like $40 per ton or so, and you can still not be sure that this is actually expressing an emissions reduction. So this is much more cost effective. You can have a much, much higher impact through philanthropy. But this is not really why we are kind of supporting this kind of work, because really the impact of this, or the impact that really makes this effective also from this perspective of mitigating climate risk and like reducing global emissions, really comes from the effect that we get through innovation. So in this case, even under quite conservative assumptions, again, about how building more carbon capture facilities in the United States affects affects learning rates and technology cost, it still looks as if like this would like reduce by 2030 would half the cost of this technology. And of course, halving the cost of a technology has like massive global implications. So this is kind of what we want. We want to shift learning curves up, and we want to increase the adoption of those technologies. And again, under very conservative assumptions. So we're just taking those assumptions further kind of to the global level. We're then getting to something like 11 cents per ton. So we're having, compared to the estimate for the US alone, something like a 15 times or so multiplier. And that's kind of really the logic behind Audacious Advocacy. So we're funding advocacy, leading to policy change. The policy change drives cost reductions. The cost reductions drive global scaling, and that's how we can have gigaton impact, and like how investments in the millions can have really important global effects on the climate outcome. But of course, that isn't guaranteed, and we can only get this kind of effectiveness if we're focusing on high impact solutions that are blind spots or bottlenecks. Because essentially, for most reasons, sorry, not for most reasons, for most areas in the world, we can always observe that the more effort we put in, the lower the additional impact. So we're having kind of a curve like this, and there are many reasons for this. First of all, if we're doing the early effort, the chance that someone else is already doing this is lower. It's a less crowded field. We're looking at a neglected field. And also, early effort is usually more impactful because it kind of shapes the trajectory going forward. And of course, also in climate, if we're looking at blind spots, because essentially we need to get to zero emissions or net zero emissions to stabilize the temperature, we also need to look at blind spots just for that reason. Otherwise, we can never stabilize the temperature. So if you kind of take those things together, this is why it's so important to focus on neglected solutions. I'm just going to give 2 examples of this from other charities that we're supporting. So one of this is carbon removal, sucking CO2 out of the air. This has recently become more popular, but when we were supporting this, it was still extremely neglected. It's essentially about making sure that we have this ability to suck carbon out of the air, because that's crucial to reach temperature stabilization at anything below like 3 degrees or so. It's not really realistic that we can do this without massively sucking CO2 out of the air. Yeah, and another one of those, of course, that neglected areas is nuclear, where we're supporting Terra Praxis, which is focused on advanced nuclear advocacy. Because yeah, despite its merits as a clean energy solution and actually environmentally a very benign solution, and I say this as someone who started as an anti-nuclear activist, nuclear is demonized or ignored in many climate conversations. So that's another one of those high impact opportunities to kind of focus on charity that tries to fix this problem. Yeah, and the third part, the third multiplier really kind of comes from doing this together, doing this in a coordinated way and co-funding. And yeah, so that's kind of why we created the Climate Fund. We've now raised about 5 million over the last 6 or 7 months or so. And really the goal here, or why we think this creates even more impact, because that's the reason the fund exists compared to just giving to charities individually, is that on the one hand, you can do things like funding guarantees. So for example, Terra Praxis that I mentioned before. So there we did the first larger grant for this. So we can quintuple the budget that they had. And this then allowed them, so we gave 250K last year that from the Climate Fund. This then allowed them to draw in at least 5 times or more in additional funding from other philanthropic actors. So you have a large multiplier for this. You can also react to timely opportunities. So after the Biden victory, we directly analyzed kind of what are the implications for this. And a week or so after we finished our analysis, we deployed over $1 million to kind of the charities, Clean Air Task Force and Carbon 180 in this case, working on those scenarios and like improving the response of the Biden administration to climate. So you can react very quickly. We're also doing active grant making, exploring new opportunities rather than just filling funding gaps, creating funding gaps or concrete projects. And of course, you can benefit from the learnings at the research frontier. So whenever we learn something where we can find, okay, here's something that's even a higher impact, then of course we're directing the money there. Yeah, and that's kind of where I want to close. The final frontier, the quest for impact multipliers. So where could we actually find stuff that has higher impact than what we're found so far? There's different things we're looking at. One is about avoiding carbon lock-in, which is because in emerging economies, emissions are growing so much faster. Can we actually affect those trajectories where those emissions rise? And can we do this in a way that's ethical? Because of course, we also don't want to keep those countries poor, right? So the goal is not to solve climate change by keeping countries poor. Another angle is, can we change the conversation? Can we shift the discourse to unlock potential? So right now, for example, the world spends something like 22 billion or so on energy innovation globally, which is like a ridiculously low amount. It's less than Americans spend on gas every month. Is there something we can do to like fundamentally change this rather than tinkering at the edges of how this money is spent? Can we really improve how much this spending is? Third one is catalytic investments that I already talked about. So this is either investing very early in organizations and high impact organizations so that they can crowd in more money and like de-risk their growth, or it can also be just supporting organizations that are going to the next stage, and then by that mechanism allow them to crowd in more money, have another multiplier there. Policy leadership is another kind of candidate. So if they're really successful policies that are copied around the world, so this would be another way to have impact on global emissions, even if you're affecting policies in one country. And then, of course, there's a cause X and a multiplier X. So what are other sources that could kind of increase impact and lead to something like outsized impact? Yeah, and to conclude, we think there are three important principles behind high impact climate philanthropy. Focused on advocacy focused on blind spots and bottlenecks, and doing so in a coordinated way. Yeah, and that's my presentation.
Excellent, thank you so much. Yeah, so we've got a bunch of questions that have come in the Q&A. We're going to try to get to as many as we can. If Johannes or John, you see any that you particularly want to answer, please let me know. Otherwise, I'm going to start with a question we have from James, which is, what are some other promising interventions that would work in low coordination environments besides energy innovation?
Do you want to take that, Johannes?
It's hard to imagine something that would, other than energy innovation, that would work in a low coordination environment, right? I mean, the one other thing that you could do in a low coordination environment is one actor could go and do geoengineering. Whether that would be a good idea is like a whole different question, and I know that John has very strong views on that question. So, but I think other than that, most other solutions like carbon pricing or international agreements or like the rich world financing emission reductions in the poor world, all of those assume a relatively high degree of coordination. It's really, I think, yeah, I would not, yeah, it's hard to come up with something that would also work in that world.
Yeah, thank you. We have another question here asking why the focus seems to be on climate mitigation and not adaptation, and should adaptation get any focus for these scenarios?
I suppose from my end, the kind of collapse scenario is quite hard to adapt to. I suppose adaptation measures for that world would be some sort of like very specific, like kind of refuge or like a plan in place if something like that were to happen. I'm not entirely sure what you would do to prepare for that, but yeah. But Johannes maybe has more to say about whether like adaptation is better than mitigation in general.
I think that's a very hard question. I think the like a challenge with adaptation is often that it's very local, right? So it's really hard to kind of get scale effect. So if if we're transforming the energy system in one country, I mean, as many countries have done, like with solar or wind, etc., this has global implications. That's often hard to think of analogies for adaptation, which makes skeptical that it could be very cost effective. I think one exception to that is, and that's also mentioned in Bill Gates' book, for example, How to Avoid a Climate Disaster, is innovation around like crop resistant, about like disaster resistant like grains. So like essentially agricultural innovation that's focused on making agriculture more resilient to heat stress, etc. So these kind of solutions, looking for solutions for the adaptation that can easily scale globally, that will probably be where I would look, and that's maybe really worth looking into.
Yeah, thank you.
So of course, if Bill Gates is already funding it, it's unlikely to be very neglected.
Yes, as is often the case, like many vaccines. I think this is directed to John. In the worst case scenario of boom and bust, if that happens, it still seems possible that humanity could survive long enough to see the planet cool back down. Even if it takes, say, 1 million years for our species to get back to where we were before this happens, is it still considered a proper catastrophe by long-termists if eventually humanity does recover?
Yeah, good. That's a good question. I suppose it depends a bit on how long you think we'd survive if we did recover, and if we rebuilt civilization entirely and then like explored other galaxies or went to the stars or something like that, then that kind of 1 million year hiatus would be kind of, I suppose, small relative to the potential that we and our kind of successors could have, like post-human successors, I suppose. I think the risk with this boom and bust scenario is just that it leaves us open to other catastrophes while we're in this sort of weakened state for tens of thousands of years. So, and then also another downside is that we've used up all the fossil fuels, which could be used to get us out of the collapsed situation, and is like, you know, they're used because they're very efficient, so that's like not a good situation. So it definitely does seem to make recovery a fair bit harder.
Yeah, we've also only just scraped through a few times throughout human history as well.
Yeah.
We have a couple questions here relating to comparing technology advocacy to other things such as alternative proteins, or this is a question from the forum that Johannes would have seen, which was looking at things like reforestation and other options. You know, in the scenarios where people, for some reason, are averse to donating to technologies, what would you recommend? And also maybe restating how big that difference really is.
Yeah, so I mean, I would probably recommend giving to carbon pricing charities. So like stuff like Citizen Climate Lobby, for example. But I do think the impact differentials are really large. So I think, I mean, so that's what I've tried to explain. Like, why should we expect this? And I think my belief, kind of from the data that I've looked at, would be something that there is like at least 100 times difference, possibly quite a bit more. And I think that the problem is, especially for, I mean, and that's I think the key problem in climate is like the stuff that's popular. I mean, on the one hand, it's rarely underfunded, but also like the stuff that's most popular in climate, like planting trees or rainforests, like that's obviously really attractive, but it just doesn't work. And the reason it doesn't work is not because trees don't absorb carbon, but the reason is that we cannot set up the institutions to actually incentivize getting additional litigation there, and that's the trauma there. And I think that's the kind of, but the evidence kind of points in the direction that this does not work, or if it works, it's not cheap anymore.
Yeah. We have one here around the backlash and animosity towards all things green, not just stemming from very conservative circles, but seemingly quite widespread. This is an EU perspective. Some of the stated motives are a fear of loss, monetary status and freedom, or just like the policies that outlaws things. Does advocacy actually have a way to change the hearts and minds, or do we aim to bypass the general public and go directly to those that make the decisions where possible? I think it actually leans towards the type of advocacy that you're referring to as well.
Yeah. John, do you want, or should I?
Yeah. I'm not totally sure I kind of agree with the premise, I suppose. I think there has generally been an increase in support for environmental things from mainstream parties in Europe and in the US, which I think, well, I don't know, maybe Johannes has a different view. I mean, probably was influenced by this sort of more grassroots approach that Extinction Rebellion and others have taken, which has like helped to get climate change up the priority list from a political point of view. And then there's these surveys in the EU of people thinking that like climate change is now a #1 priority, whereas that wasn't maybe not as true sort of 10 or 15 years ago. So yeah, I suppose that's an advert for changing hearts and minds. But then there's this question of what do we do given that we've changed them?
Yeah, and I guess there's the other thing, right? Like the backlash, where does the backlash start? The backlash starts when we talk about stuff like having really high carbon prices, or if you're in Germany, having really high electricity prices. That is why, in terms of prioritizing solutions, we need to prioritize solutions that are high impact, because those are the ones also that are ultimately going to be like politically feasible. Like, and I think that's something we see very clearly. And also where we see, like, if we're looking at the resources that we're spending on climate right now, like as a global society, like this is like, it's not like we don't need to increase that amount by like 10x. Maybe we would need to increase it by 2 or 3 times. But we actually, like, if we like improve the way that we allocate those resources, we could probably like reduce the cost like 10 times or so, right? If we would focus more on innovation, if we would focus more on kind of stuff that has global leverage. So that's kind of, if you're given the attention that is already there, like if you're focusing your philanthropy on like improving how those resources are spent, is very, very likely to be the most cost-effective thing. It'd be quite surprising if it were not.
Yeah, just to add to that, I think like the real art and challenge of climate policy is to do something that's impactful but that doesn't annoy everyone and is therefore impossible. And that like most places have just failed to do that, but it is actually possible. So like hoping on like political will for certain sort of favored solutions to kind of eventually win out against like people who care about petrol prices, I think is like a big mistake. And you can find other ways of skinning the cat that are less annoying to industries and ordinary people, but that also have a lot of impact. I think that point like often gets missed, I think.
Yeah. I'm just going to launch our feedback poll and ask that people fill that in before we finish up. I have a quick question regarding nuclear. So you raised that towards the end of your presentation, Johannes, and I've seen a lot of things around the role that nuclear probably should be playing. What do you see as the path forward for that, considering there is continuing to be reduction in nuclear in many cases and a lot of skepticism from the public?
Yeah, I mean, I think that's really the path has to go to changing heart and minds, and on the other part, the changing technology. So that's why we're so excited about Terra Praxis. So kind of the lead advocate there, Kirsty Gogan. She's, I think, if you watch her videos, you will probably agree she's one of the best advocates for nuclear on the planet, and she makes this argument very focused on the role of nuclear in climate mitigation. And yeah, I think that's kind of how it has to go. And I think it also, we don't need mass nuclear deployment in Europe, for example, or the US, right? So like the importance of nuclear is more in kind of, if you're thinking about high energy scenarios, having nuclear as a resource that we can deploy. And this will maybe not be mostly here. This may mostly be in emerging economies.
Yeah.
So I think this seems more feasible than Europe building lots of new nuclear, for example.
Yeah, I mean, it's a tricky problem because it's kind of like a nightmare from a PR point of view, because there's these very like newsworthy catastrophes that occasionally, or like meltdowns that happen. I think probably if you want it to be like a scalable solution to meet lots of energy demand in the future, it needs to be like very, very, very safe. I mean, it's already very, very, very safe, but it needs to be even safer. Meltdown impossible. So that does like make the case for the technology focused approach as well, I think.
Yeah. So we've come to the end of our time. I wanted to give you guys, before I wrap, just one final chance to have any closing remarks and anything that you'd recommend people do following this call. You can go first, John.
Yeah, donate to the Founders Pledge Climate Fund is one thing to do. Vote for environmentally concerned parties, and then I suppose there's some good books you can read. Read the Bill Gates book. Read the recent David Victor and Danny Cullenwood book. Read the Mark Jacquard book, and then you can like understand what role you should take as a citizen who's concerned about climate change.
Yeah, thank you. And Johannes.
Yeah, there's very little to add to that. I think those are all great books, and I think giving to the Climate Fund obviously is something I recommend for lots of different reasons. No, but yeah, so we're really trying to maximize climate impact, and yeah, I think those are great resources. I think also focusing on, I mean, obviously, like it's not all about donating; it's also about political action. But if you're doing political action, kind of with a view on not just increasing attention to climate, but improving the conversation. I think that's really much more important, because really we have the attention. We need to improve the conversation that we're having, and then we can improve the solutions that we're pursuing.
Yeah. Well, thank you all both so much, and thank you everyone who has come along and asks questions and been in the chat. We haven't got to all the questions that were asked today, and there's some still on the EA forum. Johannes and John, if you do have any time and want to look at them, I encourage you to do so. I can see that you already started to answer a little bit on there as well, so appreciate that. It's been really wonderful having you both. Thank you all so much, and have yourself a good rest of your weekend.